Well, hi, and thanks for joining me in my shop here this morning. So, the last video, I discovered that this radio largely works as it is. So before I go in here and start changing a bunch of parts, I thought it might be interesting to poke around with a voltmeter and whatnot, just make a few measurements, and before changing anything, try to see if there's anything out of sorts that I can spot in the radio, even though it appears to be working reasonably well. So to help me with that, I've taken the schematic diagram here, and I've marked a couple of things on here, three things. I've marked with red dots places where I should measure the B plus and compare it to what I believe it should be. That's the high voltage DC. Also, places where I should measure the bias on the tube grids, which is tricky business, but I have a number of places I might try to measure it. It's difficult to measure grid voltage without disturbing the circuit and getting a false reading. And the last thing is I've picked off 3 resistors, one here, one up here. These 3 resistors all conduct high voltage current to the tubes, and if there's a problem with these resistors, if they've gone high in particular, then that's going to reduce the B plus. So before I turn the set on and charge it all up and get it going, I'm going to check these 3 resistors, just reading them in circuit and see if what I get isn't close to the appropriate value. If it's not, then it's time to think a little more about what I found. I'm going to do this off camera because I'm going to be poking around a lot trying to locate these, but I'll show you the actual measurements when I find them. Okay, that's what I'm going to do. Oh, also, just to make me not go quite as crazy, I've also written a chart up here on the schematic, 1 column for each tube, and the plate, screen, grid, cathode pinouts, so I don't have to go running all over the place trying to find that information. Okay, so we're on our way to do those 3 resistors.
We're one of the first G7 nation to do so, so it's a great step. I'm glad to be a part of any sort of movement that has created that, but it's definitely a concerning landscape to look forward to.
That's in Ottawa, Monday night. Tickets are free. Visit our website to get yours at cbc.ca/thecurrent. Doors open at 6:30 p.m. and the event runs from 7 to 9 p.m.
Well, they didn't say what they're talking about there. I hope they would. You know, in Canada, we're just a few days now from marijuana being made legal throughout Canada. Rules around it will vary a little bit from province to province, but it will be legal and it will be available supposedly through internet purchases to start off with. And yeah, just a couple days from now. And sometime in the spring, stores will open up across Canada selling marijuana. You can, at this point anyway, the rules are surprisingly lax. So it sounds like in just a few days, if you want to go to a public park and pull out a joint and light it up, you'll be able to do that in Canada legally. Basically, you can smoke marijuana anywhere you can legally smoke cigarettes. It just floors me that it's that it's that wide open. But anyway, I won't go into that at length. Just suffice it to say, Canada's taken a big bold step forward here. I mean, the objective is to get marijuana out of the hands of high school students. That's basically, and to crush the illegal market and replace it with a properly regulated and taxed market. And I think, you know, the bulk of Canadians are happy with this. I think we're the biggest marijuana smoking country in the world, actually, and maybe even the source of a lot of marijuana in the world. Don't really know that. Anyway, that's happening in just a few days. Just a few days. Okay. Yeah, in a few days, I'll be dazed. I guess that's maybe that's how we can look at it. So I said I was going to set out to measure these 3 key resistors, and I've spent, I don't know how long, half an hour poking around. I got nowhere, absolutely nowhere. I don't know where these resistors are exactly, and got nowhere. So I'm going to abandon that. It's not a normal process I follow because of that exact experience of trying to do stuff. For instance, there we are. So I expect this reading we're getting from a resistor to be half a million ohms and I'm getting 250 ohms. So, is that resistor shorted? I don't think so. It's just, I'm just getting it all wrong here, so I'm abandoning. And what we'll switch to is checking the B plus voltages at various points. Basically, the tube plates and the tube screens where they exist, and see if those are normal. If those are normal, we've kind of indirectly tested the resistors that are feeding it. Kind of, sort of, indirectly. So that's what I plan to do here. I'm going to fire up the radio and poke around a bit more. Okay, I think I'll take a run at leaving the cameras going while I do these tests, because this should go fairly straightforward. So first I want to connect my voltmeter not to the chassis, the negative side of the voltmeter, but to the negative bus that's in here, which is up, son of a gun, up in here. Right among these wires here. Nerve-wracking sticking this in here. There we go. Okay. Should have done that before I turned the set on. Okay, so yeah, the set is operating right now, but it's on reduced current. Just waiting for, let's put it on full. Low volume. And touch the antenna. Good. Okay, volume down. So the first thing I want to measure is the voltage coming right out of the power supply, right here. So I got two big capacitors, they're both sitting here. We'll read both of them. So here's one. 265, and then the positive side of the other one is right here. I hate to say this, but I touched that wire and I think the light came on not in my head, but on the radio. Okay, I forgot everything. 235 there. 267. So this is the first capacitor, second capacitor. That's just how it is in the schematic. 16 microfarads is the second capacitor. So let me just do that one more time. This is the voltage we should find cast through the radio. 235. 235. And I have a memory like a steel box. Nothing gets out. 235. So we'll go B plus 235. Now see, now that may already be low because it's going, I'll take that back. That's what's coming out of the rectifier. Okay. Let's find it now on plate. We'll just go through the tubes this way. So plate of the 6K8, plate of the 6K8. There's two plates. Pin 6 and pin 3. Pin 6 and pin 3. So 8, 7, 6. Here's pin 6. Wow, that didn't sound very good. That doesn't look very good. 78 volts on 6. 78. And on 3. 1, 2, 3. Here's 3. That's a little better. Screen seems low. 230. So it's almost all there. 234 and a bit. It's all there. So something we might want to look into then is the plate of the triode on the 6K8. Because I really don't think it should be that low. That seems a little odd. Okay, next one is a 6K7 plate and screen, 3 and 4. 6K7. 6K7 is this one. Plate and screen. 3 is the plate. Somebody have a flashlight here. 1, 2, 3 is the plate. It's all there. Screen is 4. I just did 3. 1, 2, 3, 4. $95. Again, that's a little low. I think those two tubes share a screen resistor. So we got it all on the plate. I'm just going to put a check mark here. This thing's really bouncing. Yikes. Right there. But we found the screen to be low at 98 or something like that. Okay, next one is a 6Q7. Now, this is another complicated tube. It's got 2 plates in it. So, it's got 3 plates in it. You got 2 diodes, we won't bother with those. The one we're interested in is the plate of the triode that's in that tube, and that's pin number 3. Pin number 3. Okay, so the 6Q7 is this glass one here. Oh man, how am I going to get down in there? 6Q7, what did I say? 3? I said 3. 3. Oh, it's easy. 3 right here. Ooh, 95 again. Is that plate? 1, 2, 3. 6Q7. 1, 2, 3. No, 3. Yeah, 3 is the plate. 98 again. That doesn't sound right. And the last one is the output tube, which is the big guy right here. And it's supposed to be plate is pin 3. And we should see full voltage on this. The objective of these radios is to make the output tube work hard, so it's always got high plate voltage on the output tube, which I said was 3. 1, 2, 3. 3. Right there. Wait a minute, that's not quite right. There. So 262, so a little bit is going to be dropping through the output transformer. So from 235 it's down to 226. That's just perfectly fine. Screen is number 4. The screen is number 4. That's just, how am I going to get my probe in there without shorting something out? Down through here. 232. So the screen's got the same voltage on it. If we look at the circuit quickly, you see plate gets its voltage from this wire through the coil. Screen screen sneaks out here. Yeah, it's right from the same wire. So in fact, you'd expect the screen to read slightly higher because of the voltage drop in the coil. That's exactly what we're getting. So no problem there. Now we're going to switch to trying to read the AVC. You know, I'm not ready for that. Let's take a look. Let's continue on this and look at what's going on with the screen voltage here in the 6K8. That's a plate voltage. I didn't do the screen. Hey, what's going on? 2 plates, I skipped the screen. Okay, back to the first tube. 1, 2, 3, 4. 4 is the screen. Oh. There we go. So that's kind of the same, like low voltage. Let me write that one down. 94. Okay, so we got more on the screen than we have on the plate. There's 2 plates in this tube. So we got 4 and 6. This plate seems okay on 3. It's got 230 volts on it, but this guy only got 78. So let's take a look at this. Will both these get knocked low somehow? 6 and 4 on the schematic. oh yeah, right. Look at this crazy schematic here for this. Let's check this on the screen, on the computer screen. Okay, just before I talk, just have a listen for a bit and listen to the sound coming out of the radio. I'm pretty sure you can hear it. You hear a static for a while and then it quits. Okay, it's supposed to quit. Oh, it just quit for a moment there. So suffice it to say, maybe you can't hear this on the microphone, that there's a sound, maybe coming out of the speaker. It sounds like an electrical breakdown type sound, staticky kind of thing, and then it stops. And then it starts up again. So, who knows what that could be? Could be nothing. Could be coming in. Could be nothing. Who knows? But let's look at this now. While we listen to that sound in the background, look at this tube. Let me expand this even more. Oh my gosh. So we're finding low voltage on the plate, which is on pin number 6, which is the plate of the triode. That's here. That's this guy. He's coming in low, what looks like low, at 78 volts. So he's getting his voltage from over here. Wait a minute. Hold on now. That's one of my meters saying goodbye. Well, this plate is hooked up to the same wire, basically. So plate on the 6K7. Oh, that's strange. You know what? I didn't write down the number. I checked it off because I remember it was very high. How can you have a high reading here and not, because I've got this backwards. I must have this backwards. So what have I got backwards? The high voltage is here on this plate. It's this plate here that's failing to develop the high voltage. And it gets its voltage through these two coils, some resistance in those coils, and through this guy. 5600, half water. Now, let's look at this. There's a screen up in here. Believe it or not. Is there? Wow. So here's the screen. Looks like two screens. So you can see it here quite clearly. That's a screen grid. So the screen's getting its voltage here. Well, the other side of this resistor. So this resistor is not so implicated in low voltage on this side. The screen over here is reading low also, 98. Maybe that's correct. So you have 98 volts here on this line. 98 volts on that line. Yeah, how do you move this? Oh, you move it like this. 98 volts here. We get to here. So this would be the plate, driving the plate on the 6Q7, and I got on the plate 98 volts. So we're low everywhere on here. That's a pretty substantial resistor there, 270K. I gotta try to find this resistor. Here we go. I gotta find this resistor and read the value of it and read the voltage drop across it. So let's just think about this for a minute though. It's just 14, looks like, 14,000. Really? Okay, something like 14,000. That looks like a 1 there. 10 to 20,000 here. Is it set up as a voltage divider? I don't think so. Not yes and no. No, in the sense that there isn't another resistor going back to the chassis like this arrangement here. This is a voltage divider arrangement. I gotta find this guy and check him out. I think that's the only thing I can do. R12. Good luck finding this. This could be anywhere. This could be anywhere in that radio. 10%. What's that say? Does that say 2 watts? 1 watt? What's that say? You can guess this is a fair size resistor. Son of a gun. How am I gonna find that? I'm gonna be searching long and hard for that. Okay, that's what I gotta do. There's no other way around this. Okay, so I decided, hey, if I'm gonna have this radio on, I might as well have it playing. So I've hooked up an antenna and we're listening to an AM station. I'm just about to use a new feature on this meter, which oddly enough, I never thought it would be of value, but I'm about to try it out. So let's check it together here. So I'm trying to convince myself I have to find this resistor right here, but for the life of me I can't identify it. I just can't be sure of anything in here. The parts are too packed together and the like, and I'm going crazy trying to trace it out, so I don't want to do that. So what I'm going to do is I'm going to measure the voltage here. That's the output of the power supply. Should be the same voltage as the bottom of the resistor I'm after. After I measure it, get it on the meter, I'm going to push this relative button here, and that will subtract away that voltage from future readings. So if I manage to hit the bottom of this resistor, I got a couple in mind I'm going to check. The result of that should be 0 on the meter. Everybody got that? So what's all that static? Where'd my station go? Oh, I turned the volume down. Fix that easy. Okay. Voltage that we want to zero out essentially. Oh, that button's stuck. Yeah, that didn't do a thing. There we go. Okay, so I guess I didn't hold it long enough, perhaps. Yeah, now with 0, you're going to see a minus amount. Peanut, please. Come on. Man, I tell you. Cats. He just came in, he wants to go right back out. Well, let's finish this test and then I'll take care of him. So, yeah, no. Okay, so the other end of one of these resistors. Oh my god, I gotta shove this into an operating radio here. Hello? That's what he's saying to me. What do we get? Okay, that's not it. There's just so many parts all jammed in there, I cannot see the lead from the actual lead I'm after. Here's another lead. That can't be it. It can't be it unless, I don't know. See, this is and there you are. That's how to use this new thing. Well, to demonstrate this feature, I'm going to just put this on the other capacitor and we should see a difference. 33 volts difference. So we know there's 33 volts dropping across the field coil. Unless this doesn't say 0. It says 0 still. So it's holding the relative thing. Why this meter has to beep every time it auto ranges? It's really kind of annoying. Well, what am I going to do with this now? What have I got? Okay, there's another huge wattage resistor way up here in a stupid place, but let's try it out. Okay, so that's not a 0 on one end, and the other end is scarily up in here. Hey, look at that. So these resistors that are kind of in the circuit with, they're not necessarily attached right to a tube pin or something like that. My God, they can be anywhere in the radio based on wires running all over the place. So, you know, a resistor like this might be pictured in the schematic here, but physically it could be located, who knows, physically up near one of these tubes, nowhere near the power supply. That appears to be the case. So, if this is a 14,000 resistor, which I'm not sure it is, then it would be brown, purpley, orange. And what I can see of this resistor up here is this great big guy. This one here. I can see brown. Body and dot. Brown body. Body end. Hey, there is an end there. Black. That's 10. So that's 10 something. 10, I don't know. But that's my best. Maybe it's 10K on the schematic here because it's just really not readable. But for sure, I mean, what other resistor could I get a 0 on this leg? Is there another resistor somewhere in here? No. Make sure I follow the right wires. No. No, this is the only resistor it could be that'll have 0 on it with the relative measurement I'm taking. That's got to be it. So at the top end of that, then, we should be finding the 98 or the whatever. So I want to turn off relative. Yeah, let me read this. Okay, maybe I do that. That's better. So go away from relative measurement to this measurement. Which measurement? This one. And what is that measurement? There's the low. There's the 98. So the question is now, is that correct? Is that what it's supposed to be? Or has that big brown resistor gone crazy? It's easy to test that resistor, I think. If I leave it in the circuit, wow, lots of stuff going everywhere. But this basically goes nowhere from an ohm reading point of view across here. I'm looking for anything that might kind of parallel this. Logically, there shouldn't be anything paralleling this, I think. So I should be able to just go ahead and read it right in the circuit, but not, of course, with the radio running. Well, another thing I can do is I can do the, well, I can't. I was going to say I could do the current through it and the voltage drop. I don't know the current through it. I can't figure that out. Okay, switch off. We'll check right away for residual voltage here. Wow. What about down here? Really? Did I disconnect something? I'd like to see something. Anything. For real? Is this meter working? Did I do the right thing here? Volts. Volts. Okay, it's a stupid thing. I'm going to turn the set back on just to get a little voltage here, just to reassure myself. Yeah. Just watch it go down. Okay, that's not bad. That's okay. It's not really okay. I want it to be 0. Before I make a resistance measurement. Let's help it out. By the time I get that on there, it was going to be 0 anyway. Okay, that's all the help it needed. Double check. Voltage, double check on the resistor up there. And down here. No voltage. Okay, so we're ready to take a resistance reading. Good. Gonna clip this. On one side of this resistor, I can do it right up here actually. Okay. The other side I'm going to contact with this. What are we thinking? We're thinking 10 or 14 or something like that. What's going on there? Getting all kinds of readings. 18. Okay, Peanut, hold the fort. Okay. He knows what meows get me, get my heart. Isn't that right, Peanut? Yeah. So there it is, 18K. 18K. How can that be a problem of any significance? There they are, the dynamic duo. Peanut's taking the lead. Peanut is said to shadow in the background there. I'll get the guy. Now notice he's not coming in. He's in the doorway because he wants me to go out. Now, let's just test it again once more. I've done this before. I'll take one step towards him. Peanut, watch. Oh, he doesn't want to go out. Peanut's a wonderful cat. Yeah. Yes, you are. Okay, I'm a cat person. I like looking at my cat. What can I say? Jim's a great guy. This cat likes being picked up and held. My other cat doesn't like it at all. Okay, putting you down. Putting you down. Is that good enough? I got you all charged up now. Wait a minute. The human's not following me. Peanut? Okay, enough silliness with the cats. I better go let them outside. Okay, so if we add up some evidence here, first of all, we're reading almost 18K on this resistor. Resistor, we can see it's got a brown body. We can't see the, it's brown, black, and we can't see the dot. The dot is hidden behind the resistor. So brown and black, though, is 10. But look at this very carefully. I blew it up on my computer screen. This could easily say 10. This could easily say 10K. It's a 10K resistor, and it's reading at 17. That's not very good. Coupled with the fact that all these voltages seem low out here, I think we got to take that resistor out and take a good look at it. And I'm on my way to replacing it, and I'm going to have to go probably with a 10K. But once we get the resistor out, we'll be able to see what it is. And before I do something really stupid, oh, set's already off. That's sort of, was that two wrongs making a right there? Okay. Set's off. We're just going to clip out that resistor and take a look at it. Let's see. This is the biggest, baddest resistor in this whole radio. At the same time, I think we're gonna change this big honking capacitor here because it's just in the way. A lot of them are. This capacitor appears to be hooked to the ground terminal on the back, but just out of sight, and I saw it just a bit ago, there's actually a wire from the ground terminal straight to the chassis. So all that's happening is this capacitor is finding a ground point there. And you can't see it too good in the camera, but there's an extension wire on it. So exactly what somebody was trying to achieve here. It's got to be a replacement. This has to come off. There. Okay, let's take this right out. .25. I think there's a capacitor, a .25 that is supposed to be in that, or going to ground from the terminal I just cut it away from. So I think that's correct. It's just kind of big. Now I can get at the resistor here. I'm going to leave some wire behind, or I know what'll happen. I'll forget. There we go. There it is. What's the dot? The dot is orange. Brown, black, orange. Dot. Silver N. 10K. Oh, let's check it with this one here. Is it 10? No, it's actually 17. It really is 17. So great. This out, this is going to jack up the voltages in the radio. It's going to make it work better. I just have to get a 10, a high wattage 10K resistor. So I will do that. We'll stick it in there. Okay, so as it turns out, I don't have any brand new 10K high wattage resistors. I guess I've used them. There's nothing in there that's really going to help, but I did find an NOS, new old stock, high wattage resistor. This is a really high wattage. This guy, 10 watt resistor. He called it a coulomb. Coulomb. I got to show you that on the camera then. Hey. Take a look at this. So I don't know if that's a play on the word Coulomb, made by Sprague. Okay, don't know what the 10N something is. 10 watt, 10K. It's in really good shape. Never been installed anywhere. Got long lead wires. It's my radio. We just need to take a little measurement here of the actual resistance. So it's not 10, it's 9.25, 9.25. I don't have a problem with that. I'm going to give a little extra voltage to that front end too. Make that radio work even better. Okay, more voltage all around, everybody. So I'm going to install that. Now I also popped out this capacitor. Why don't we test this guy right now? Why not? Test him right away. Okay, so you can kind of see the gap there. 25 volts. Good show, Jim. Here we go. Okay, it opened. Took a little while, but it's a big, relatively big capacitor. 150 volts. Yeah, it's not going to make it. So he's leaky. No surprise. Again, this is kind of a qualitative test or a comparative test, and I've got enough experience now. I know what a good guy and a bad guy and a tired guy look like. That's a tired one. So I'll replace that capacitor. So I'll put in a resistor, a brand new capacitor, and we'll see what happens to those voltages. Okay, so I've got the new resistor, the new old stock resistor here, new capacitor installed there. So yeah, this has got to boost the radio's voltages that we were measuring low. Let me get ready to measure them again. So we're going to put this on the negative bus, this radio, which is way under here. The chassis is not the negative bus in this radio. Oops. And one of the hints that that's the case is lack of a cathode resistor on the output tube. The output tube has to get its bias from somewhere. It's not getting it from a cathode resistor. It's probably getting it from that power supply trick that I failed to explain. So we're going to put this right on the we want to put this on one of these spots here that measured low. So let's try a plate of the 6K8, and the plate is pin number 6. So 6K8 pin number 6. Where'd my little flashlight go here? So 8, 7, 6. Okay, so last time around this measured 78 volts. It's really very low for any plate voltage. So volts. Double check here. Okay, just to make sure we got a positive where I expect the positive voltage to lift. The ground on the meter is where it's supposed to be. Negative terminal of this capacitor, in fact, is what it is. Otherwise, the radio is the same as it was. Not quite. Not quite. Well, it's okay. Everything's fine. Good show. Don't say anything. Just turn on the switch. Okay. So this is with the restriction. That's a little higher. Now it'll pull down. Just hang on while the tube, wait for the tube to conduct. There it goes down. Okay, I'm going to give a full voltage here. I'm going to go back up. Settling in around 100, which is pretty low, eh? 100. And let's just .28, no heat in that resistor. 100 volts. Okay, so what is it supposed to get? 6K8. Let's see what the good book says about a 6K8. 6K7, 6K8. Converter service. This is 2 tubes, and the one I'm concerned about, the plate I'm concerned about, is the plate at pin 6. The plate at pin 6 is the triode plate. I got that all turned around before. I don't know. Okay, but it's a triode plate we're reading now anyway. 100 volts. So come down here, hexode, triode plate voltage. 125 max. Aha! Yeah, I don't like those sounds. So we're good. I think we're good. There's typical operation here. Typical operation. Triode plate current. Triode plate voltage. Typical operation 100 volts. Whoosh. Hey! How about that? We're right on the money. So that was a good move. We'll just check a couple other voltages. They should all be okay. So I'm going to pull off this clip lead here. There we go. So another one worth testing would be the screen, which is pin 4 on the same tube. 1, 2, 3, 4. It's kind of back here. Well, you know what? That's right here. It's the same thing as right here. 124. And the plate on the heptode side was already running at 238. Screen on the 6K7 pin 4. 6K7 pin 4. Screen 1, 2, 3, 4. This was running low. It's 124 now. It was measuring at 98 before. Screen on the 6K7. 124. Screen on the 6K7. Where did I put my book? Screen on the 6K7. Let's see what the book says. 6K7. Uh-oh. It's not going to say much here. 6K7 discontinued. It's all written in here. Grid number 2 volts, 125. And grid number 2 is the screen, 125. And what did we get? What did we get? That's exactly what we got, wasn't it? Screen was this one, wasn't it? Too many questions being asked. 124, look at that. So she's a thing of beauty now. It really raises the question, why would I bother changing any more parts in this radio? We haven't yet looked at the AVC voltage and tracked through that and see if we can find any weaknesses in it before I start wholesaling these capacitors out of here. So I think that'll be the topic for tomorrow. AVC. AVC action in this radio as it stands. What about it? Great. Hey, thanks so much for watching. And see you on the next video.